So warm-up number 53, we already finished. It's very similar to the one we did before we went to break. And now we're going to get started with our review for our semester final, okay? So with that said, let me get this in front of me. So I can master all semester one concepts and skills. So, one variable equations. Think about it without looking at your notes. Talk it over with your neighbor. Let them know a definition for a one variable equation. Definition for one variable equation. All right, Rodney, one variable equation. Help him out, Natasha. Claire, one variable equation. What? Nayeli, what do you think? Equation with one variable. What? Yes, it's an equation with one variable. My goodness. All right, let's move on. How about polynomials? Think about it. Now, I hammered this one like big time. Talk to your neighbor, let them know what definition for polynomials. Polynomials. All right, I think William's got this one. William, go. Polynomials. Nothing. Okay, once again, people stay focused. Get off those computers. My goodness. Alexa. H, yes. What? Andrew P. Addition and subtraction of monomials. Let's go from the corner. Yes, monomials or sum or difference of monomials. All right, move on. Quadratic equations. Quadratic equations. Talk it over your neighbor. What is a definition for quadratic equations? Definition for quadratic equations. And I think we're going to come back to William on this one. I think he's got it. Quadratic equations. All right, let's go with Diego. What do you think, Diego? Quadratic equations? I'm sorry? Something with what? Something with a zero? Okay. I guess all the definitions could be with zero, right? Anything can have zero. That's pretty good. Diego, my goodness. Help him out, Luis. Polynomials. I'm sorry, quadratic equations. Look at Luis. Oh, that turkey kicked in. Two variable equations, highest degree of 2. Two variable equations, highest degree of 2. Could it be higher? No, because then it would be a cubic or a quartic or whatever the case. All right, so far so good, yeah? They're like, oh yeah, Mr. Gill, I'm ready for the final. Oh yes, we got this. Rational expressions, rational expressions, all right? Talk it over to your neighbor, what are rational expressions? Rational expressions. And this one, we're going to bring it over here to Brooklyn in a little bit, as soon as I let you guys talk about it. Rational expressions. Rational expressions. All right? Let's see. I was going to go with Brooklyn, but I'm going to pass it to Starla. Starla, go. Rational expressions. Oh, Brooklyn's got it? She has it? All right. Brooklyn, go. Help her out, Ayalani, help her out. Ratio with two polynomials, yes. Or, in your own words, what's another word for ratio? Fractions with polynomials. Come on, people. Fractions with polynomials. We saw some of those. Next. And the last one before we get into some problems. Function. Now, you guys better know what a function is. We saw this for about 3 weeks in a row. Talk over there. What is a function? Function. I think Addie's got this. Very good. Savannah's got it. Yes. All right, Savannah. Kristen's got it. Let's go, Kristen. All right, but we're going to go with Alexa L. Something about input and output. Yes, very close. For every input, there's exactly one output. Yes. But what is the one key word at the beginning of all the definition? It's a what? Relation. Relation. Yeah. You went home and you had like a lot of people over. They were some sort of relation to you. Yes. All right. So with that said, get a you have your Cornell note out? Yes. All right. Copy this graph, please. Number 1. There it is on the screen. I'll leave it there for a little bit. I'll give you some time to copy that, and then we're going to get into the domain and range with all three notations. Copy and go. All right, here we go. It says, describe, my bad, let me scroll up. It says, write down the domain and range of the function as an inequality, then using a set notation and interval notations. They want all three of them. And they want it for both, for the domain and range. But then it says also describe the end behavior. So today we're going to close that section up in regards to end behavior. So they give us the graph f of x equals negative x squared plus 3. And notice when it's a negative, it's an upside down parabola. All right. So on the side, I'm going to write D for domain. We're going to first work with the domain. So I'm going to take my highlighter, and we're going from left to right. What's the farthest to the left that I'm going to highlight? It looks like the farthest to the left, I'm going to what? Negative 3 of x. Do you guys see that? How about farthest to the right? Farthest to the right would be what? Positive 3. Okay. However, look up, please. So this is true according to the graph that we have in front of us up to right there. But what do we know about these arrows? That they're going to continue growing the graph. Is that correct? So do I stop highlighting at negative 3? No, it's going to continue going to what? To negative infinity. And this arrow, since it's going to continue growing downward and also to the right, it's also going to continue our highlighting all the way to positive infinity. So that means my inequality would be negative infinity less than x less than positive infinity. Yes? All right. So write me the set notation for that one, and then I'll ask Starla for it. All right, Starla, solution set of x such that negative infinity less than x less than positive infinity, close bracket. Yes. Interval notation, we only need the negative infinity, comma, positive infinity, and these are parentheses and parentheses. So this is our inequality, set notation, and interval. All right, next we're going now with range. I'm changing colors to blue. And now we're going to highlight from the bottom to the top. From the bottom to the top. What's the farthest point on the bottom that we go according to this graph? looks like negative 6. What's the highest point? The highest point is 3. So according to what we have here, 3 is the highest, negative 6 is the lowest. However, what do we know about the arrows? That it's going to continue going to what? Negative infinity. Thank you. All right, so therefore, we have negative infinity less than f of x less than or equal to 3. Why did I put equal to 3? Because this is a solid point. It's going through that graph. So write me the solution set, or the set notation, and the interval notation. All right, set notation is solution set of f of x such that negative infinity less than f of x less than or equal to 3. Interval notation, I got negative infinity, comma 3. Negative infinity is parentheses, and the 3 is a bracket. Hands if you got that. Yes, some of us. Okay. All right. Now, let's do the last part. They want us to address the end behavior. So I want you to write end behavior, and I'm going to elaborate on this so that we can see how it's written. Here it goes. So let's look at one of the ends of the graph. This end on the left side, it looks like it's an arrow and it's going downward. Is that correct? But what's happening to the x? It's going to continue going that way. Is that correct? All the values are going to continue growing until they get to what? Negative infinity. The arrow means that as it continues to grow that way, it's also continuing to grow downward, so it's going to go towards what? To negative infinity. So this is how you write the end behavior for the left side. As x, write this down, approaches negative infinity. Here we go again. As x values approach negative infinity, comma, my f of x values continue approaching what? Negative infinity, because they keep going downward. I'm going to put semicolon. Next, now I'm going this way. As my x values approach what? Positive infinity. What's happening on this side? It's going to continue going towards what? Negative infinity. So we write as x approaches positive infinity, comma, f of x approaches negative infinity. That's how you describe the ends of the graph. You go with the left side, and then you go with the right. All right. So, and let me be specific with this one. Now, check this out. You don't need to be, or you don't need to understand sports for me to ask this question. Here it goes. Ready? Let's say I wanted to get really good at shooting a basketball from anywhere on the court. Let's say from the line that's close to the three-point line, per se. What do you think I need to do in order for me to get really good from shooting it from that spot? What do you guys think? Practice, yes? All right, but what does that mean? How do I practice? Shooting it a lot of times, yes? Like maybe shooting it 1,000 shots every day. Would that help? Of course. 1,000 shots from that spot is going to create muscle memory as I continue perfecting my technique to shoot from that spot. Tonight's home plate, you're going to do numbers 1 through 7. Even though this is number 1, you're still going to do it one more time by yourself. Why? Because I want you to go through the process. Why? Because you need that muscle memory. Why? Because next week when we cover our final, our 3-day final, we have all concepts in 3 days, and your brain needs to do things automatically. There's no multiple choice. You have to know everything by step by step. Okay? Once again, it's only 25% of your grade. No biggie. Only 2.5 letter grades. Thank you, Mr. Q. You're welcome. All right, move on. All right, send me a picture of what you just did so I can see your notes. 2. Copy this one, please. Number 2. Let me zoom in. It says fireworks. A fireworks projectile is launched at 20 meters per second from a 60-meter cliff. The table shows the height in Y in meters. The projectile is above a field after X seconds. So I want you to copy just this part where we're going to graph and copy the table. Only those two. Okay? Copy that. I'll give you some time. All right, here we go. So this is problem number 2 from the final. There's one similar to this one as well. So basically, they want us to plot the trajectory of that projectile, which is a fireworks, whatever the case. Now it says they're starting at a cliff that's 60 meters high. Now, I don't know if you guys been to, let's see, where do we have cliffs in San Diego? La Jolla, have you guys been to La Jolla, some of you? You know how you look down on where the seals are at? If you stand close enough, that's a cliff. There's a cliff right there. If you go to Torrey Pines, when you're headed up to Del Mar, but right past the Torrey Pines beach, there's a cliff where you can get off and walk around. You can look down, just, you know, careful, and that's a cliff. You know, there's plenty of cliffs. So imagine you're up on the cliff and you're about to launch a firework up in the sky. So where do we start? We're up on the cliff, so we're up high at 0 seconds. We are already at what? At 60 meters. So plot your point at 0, 60. So that's where we start, 0, 60. So as soon as you fire it up, it starts going upward. So after 1 second, where are we at? After 1 second, we are at 75 meters. 75 meters is about right there. Next, 2 seconds, we are at 80 meters. 3 seconds, 75 meters. 4 seconds, we are at 60 meters. And 5 seconds, we are at 35 meters. So 5 seconds, that's 20, 30, 5. All right, so let's sketch our trajectory of the projectile. So we start going upward, and then here it starts going downward. And for the sake of the table, that they only give us those amounts, I'll stop right there. But obviously, look up please, obviously you understand that the projectile, the fireworks, does it stay up in the air at that spot? No, it's usually going to probably fall somewhere over here. Is that correct? But I'll leave it at that point. Okay? So, with that said, let's answer the question. A, plot the points, make the curve. Did I do that? Yes. Make sure you address that. Pay attention to this. Look up to the screen. Did I plot the points? Yes. Did I make a curve? Yes. Now, I'm telling you this because other years I've had students that plot the points, and guess what? They don't make a curve, so I dock a point. What does it say? Plot the points, make a curve. Okay. Step number 2, it says, what is the maximum height of the projectile? Tell your neighbor, please. Maximum height. Everyone. It's right here, which is what? 80 meters. So for part B, just put 80 meters. 80 meters. Next, I'm going to switch to red. Over what interval, notice that here what they're asking for interval notation. Over what interval is the projectile's height increasing? So look at it. Where does the projectile height increase? The height increases all the way from 60 to what? To 80. This spot right there. So, from where to where in height? In height. From 60 to what? 80. So how do we write that in interval? Bracket 60, comma, 80, bracket. And that is in meters. However, I also want you to show me the interval for that section, but for the seconds. So you never the interval in seconds also when the projectile is increasing in height. What is the second in interval? All right. Second, intervals. Maddie, go. Help her out. Illy. 0. Let's see. 0 to 2. That is correct. And that is in seconds. Notice it increases from here to here, so that means from 0 to 2 it's increasing. Is that correct? Yes. So with that said, look at part D. Over what interval is a projectile's height decreasing? So let me go to decrease. It's decreasing from here to here. From here to here. So write me the interval for the meters and the interval for the seconds when it's decreasing. All right, so it's decreasing from where? From 80 all the way to where? This is what? 35? It's from 80, comma, to 35, bracket and bracket. And that is in meters. How about in seconds? From where to where? From 2 to 5. So from 2 to 5, and that is in seconds. That one is problem number 2. Let's go to the last one for today here in class, but for home you're going to do all the way up to 7. Okay? Here we go. Copy this one. Let me zoom in. It says, describe how to transform the graph of f of x equals x squared. So right away they're asking us to graph f of x equals x squared. So copy this, and I want you to graph me f of x equals x squared without a table. By now you should know how to do that, yes? Yes, yes, you do. All right, good. Let's see. F equals x squared. Oh yeah, it's negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And that is f of x. But they want us to now graph according to this. So let's see. We have g of x equals 2 times f of x plus 2 squared minus 3. Where's the minus 3 going to take the whole function? Down, very good. How about the plus 2 inside of the parentheses? It's going which way? To the left, very good, William. So we got 2 to the left, 3 down. We know we can do that at the end. But now we need to figure out the 2. So that means it's going to stretch it, right? So check this out. What was the original y value for these 2 points? Look at this. The original y value was what? 4. And now the new one is times 2, so the new y value would be what? 8. So 7, 8, which is over here. So my new 2 points should be up here at 8. So what's the original y value for these 2 points? The original one is 1, but since we're multiplying times 2, so my new y value is at 2 for this one and this one. So here's a stretch. Here's a stretch. And now what do we do at the end? 2 to the left and 3 down for each of those points. 2 to the left, 3 down, 1, 2, 1, 2, 3, and that's how you move all of these. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye. What? 1, 2, 3. And that's g of x. Problem number 4. Given the graph f of x equals x cubed, it's already there. Graph the new translation, 3 steps to the left, 2 steps up, and write the new transformed function. All right, so copy that on your paper first. Let me zoom in. There it is. Copy that. And then we'll do the translation according to the instructions. And then we'll write our function, our new function. Copy and go. So they give us f of x equals x cubed. So label that graph, the original that you just did, label it f of x. There it is. And then the end graph is going to be g of x, yes? All right. So they want us to translate this one according to these instructions. What are they? 3 steps left and 2 steps up. So let's take each of these points, 3 left, 2 up. So we got 1, 2, 3, and then 1, 2. This one, 1, 2, 3, 1, 2. This one, 1, 2, 3, 1, 2. And then let's make our graph. Oh. There it is. And what are we going to label this one now? Yeah, g of x. There it is. Okay. All right. But here's the good part, though. It says, write a new transformed function. So we need to write our general rule. Is that correct? So here's our general rule. Let's write our rule first. Our general rule is g of x equals a times f of x minus h. And this one is a what? A cubic, yes? So we put a little cube right here, plus k. All right, so according to the steps that they tell us, look up, 2 steps up. Where does that go? Tell your neighbor, please. 2 steps up. Which parameter do I use? A, h, or k for 2 steps up, everyone? K, exactly. So we put positive 2 for k. That is correct. What else? 3 steps left. What does that mean? Minus 3, yes. And where does that go? In the h. So I'll write negative 3 underneath the h. All right, that's all we did? Yes? So we don't need which one? A. So erase the a. And now we just write our new one. G of x equals f of x. Now check this out. Be careful here. Look up. This is negative 3, yes? What is negative 3 times a negative? Positive 3 cubed plus 2. And this is our new function. So once again, you need to write your general rule. Just substitute the values of whatever it is that we did. And that's the end product. Yes? The cube is the type of function, is this type. Right here? It's actually negative. What did we substitute in there? Negative. So the negative 3 goes in here, but negative times the negative became a positive. Yeah, so this is one thing that you guys need to remember, that part of the form, it's always a negative in there. Okay? All right, let's move on. Actually, send me a picture of what you did so I can have some notes on that. Thank you for submitting your work. Let's go to number 5. Number 5. All right, let me zoom in on mine, but it's on your screen and it reads, find the inverse function for the given function f of x. Use composition to verify the functions are inverses, then write the function and its inverse. In this case, I don't want you to verify it, I just want you to find me the inverse. So for this one, instead of writing all the instructions, just write number 5, and I want you to write f of x equals 3/4 x minus 1. 3/4 x minus 1. All right, and then I'll give you some time so you can make a little coordinate plane on the side because we're going to graph both of them, the original and the inverse. Copy that. Y'all ready? Okay, here we go. Before I do the inverse, I'm going to graph this one. Ready? Yeah. Oh, sorry. Let's graph this one. And I'm going to graph it without a table because now we know how to graph it using slope-intercept form. Is that correct? Yes, Mr. Q. So where do we start? We start at -1. So go to -1, which is right there. What else do we need? We need the slope. Now, for those of you that forgot, this is the form that we're going to use. Y equals mx plus b. What is the plus b? The y-intercept. There it is. We need the slope. The slope now is what? 3/4. That means 3 steps up, 4 to the right. So we go from here, 1, 2, 3, 1, 2, 3, 4. If you want to do it one more time, that's fine. Let's do 1, 2, 3, 1, 2, 3, 4. Get your straight line going through those points. Arrows at the end. All right. So I just graphed that one. So now let's find the inverse. All right. So, before I start, tell your neighbor the first thing you need to do to that one to start getting it into the inverse. Then we'll ask Ivan for it. All right, what do I do first? Ivan. Very good. Change f of x to y. Very good. Y equals 3/4 x minus 1. Continue. Diego Romo. Add 1 to each side. That is correct. We're left with y plus 1 equals 3/4 x. Jessica, next. So 3/4 is multiplying. So to get rid of it, we need to multiply times its reciprocal, which is 4/3 to both sides, times 4/3. Because this becomes 12/12, which is what? 1, and we're left with x. Distribute. This is 4y plus 4/3. 4y plus 4/3. What do I do next to make it the inverse? You change the variables, yes. So I'm going to exchange the x and the y. So this becomes 4x plus 4/3 equals y. Can we leave it like that? No, Mr. Q. All right, so this is, I'm going to go this way. 4x plus 4 over 3 equals f inverse of x. However, how can we graph this if it's a huge fraction? Let's rewrite it, yeah? Can we write it as 4/3 x plus, what is 4/3 in decimal? 1 point what? 1.3. All right. So let's graph this one. Where do we start? At positive 1.3. Positive 1.3. All right, let's go to positive 1.3. 1.3 is about right there. What is our slope? Fredo. Four over 3, which means 4 steps up, 3 to the right. So let's go 4 steps up from there. Here it goes. 1, 2, 3, 4. 3 to the right. 1, 2, 3. And let's graph our line. Arrows at the end. So, this is f of x. What do we label this one? F inverse of x. Now, let's make an observation. What do you guys notice in regards to those two in the graph? You notice that they're kind of like mirror image from one another? You guys see that? Yeah? Yes, Mr. Q. All right, good. What's that? Yeah. All right. There's one of these on the final. This is number 5? Yeah. Okay. Let's go to number 6. Woo-wee. Oh, my bad. Before we do, send me a picture of your notes. I want to see that. All right, number 6 is on your screen. It says, isolate the absolute value expression in the following equation to determine if they can be solved. If so, find and graph the solution. If not, write no solution. So copy that, please. And they give us the equation -8 times the absolute value -x minus 6 plus 10 equals 2. It's an absolute value. Yeah. All right. So let's get to this. So I'm going to write it on the side to do the work, and then I'll leave the graph right there so that we can graph it there. So I'm going to write my equation, -8 absolute value minus x minus 6, close the absolute value, plus 10 equals 2. All right, remember absolute values? Oh yes, Mr. Q, I love these. All right, line down the equal sign. We need to leave the absolute value by itself. So circle the absolute value. And we need to get rid of everything that's around it. What's around it? the multiplication of negative 8 and addition of 10. So I'm going to start with addition. So how do I get rid of that 10? Minus 10 minus 10. We're left with negative 8 times the absolute value, negative x minus 6, equals negative 8. What's left outside the absolute value? The negative 8 that's multiplying. So what do? Divide by negative 8, both sides. That leaves us with absolute value, negative x minus 6, equals 1. All right. So, let's see. What do we do from there, since the absolute value is by itself? Tell your neighbor, and then we'll ask Frida. Tell your neighbor what we're going to do right after that. All right, good conversations. Frida, next step. Very good. She said 2 equations, one for negative and one for a positive. So this one becomes negative 1 over here, and we write whatever's inside. And this one is a positive 1, and we write whatever's inside, negative x minus 6. And we solve each one. So, solve this one, plus 6 plus 6. We end up with negative x equals 5. What's our last step? Divide by negative 1, divide by negative 1. So x equals negative 5. Next, solve the other side. Plus 6 plus 6, negative x equals to 7. So now we just need to divide by negative 1 to get rid of that negative. So x equals negative 7. So what are my solutions? Negative 5 and what? Negative 7. All right, let's go to our line. Negative 5, where's that at? Negative 5 is right there. Oh yeah, I did that on purpose, see if you were paying attention. Negative 5 is right there. And negative 7 is right there. Negative 7, negative 5. Are we done? No. How do we write the solution of an absolute value? You guys remember? Good. Solution set, negative, we go with the farthest to the left. What's the farthest to the left? Negative 7, comma, negative 5. Is it coming back, some of you? Yes? Yes, is it you? Okay. All right. So once again, we need to solve it first by leaving the absolute value by itself. After that, we set 2 equations, one for the negative, one for the positive, without the absolute value for both. Solve, and that's how we plot and write our solution. All right? Send me your notes really quick, and we'll move on to number 7. All right, number 7, it says, solve each problem using an absolute value inequality. And it reads, on an average, a squirrel lives to be 6.5 years old. The lifespan of a squirrel may vary by as much as 1.5 years. What is the range of ages that a squirrel lives? All right, so for this one, instead of writing the whole thing, since you are going to look at it on Canvas, let's start with our form. Hold on, let me show you really quick. Write number 7. And we're going to start with our form. Who remembers the form for writing absolute values? Yeah, good. So we do absolute value x minus blank, close absolute value equals blank. You guys remember that? Yeah? All right. So, let me go back to the previous problem, though. Look up. In this problem, Which one became positive and negative? The number 1, right? The one that was by itself. Okay. So let's go to the problem at hand. Look at this one. Let's read the problem. It says, on an average, the squirrel lives 6.5 years old. The lifespan of a squirrel may vary as much as 1.5 years. What does that mean? Either more or, so where do we put the 1.5? Tell your neighbor, 1.5. Yeah, very good, outside, 1.5, because this one is the one that becomes what? Negative and positive, yes, 1.5. 1.5 negative. All right, next. That means the 6.5 goes right here. So that means we write x minus 6.5, x minus 6.5. And we solve. Plus 6.5 plus 6.5. So we end up with x equals 6.5 minus 1.5 is 5. Yes, 5. Okay. This one. Plus 6.5 plus 6.5. 6.5 plus 1.5, what is that? 8. So what would you say? The question is, what is the range of ages that a squirrel lives? Yeah, a squirrel lives between 5 to what? 8 years. 10 years. Woo-wee. All right, so for tonight's home play, numbers 1 through 7, the first part of the video is going to be in the YouTube channel, so make sure you go over there, look at all problems if you need to revisit, and those are due tomorrow. Have a good one, guys. See you guys tomorrow. Bye.